All right, so we want to look at index numbers today. If we're able to finish and we can take another one, fine. So under this, we want to look at the index relatives, then the simple aggregate price index, weighted aggregate price index, the last Perez, and the Pashi indices. We'll compare the last Perez with the Pashi price indices. And we also state the uses and the limitations of index numbers. So that is what we want to look at for now. Now, index numbers are often used in stabilizing the time value of money and deflating nominal values. An index number measures the percentage change in the value of some economic commodity over a period of time. Index numbers are expressed in terms of a base of 100, so like 100%. So that is how we express them. Now, economic commodity is a term used to describe anything measurable and has some economic relevance. For example, the price, wage quantity, productivity, expenditure, and so on and so forth. They are all referred to as economic commodities. So if one day I ask you to explain what economic commodity is, you should be able to explain. Now, 2 or more time periods are usually involved in the computation of an index number. One of these time periods represents the base time period. The value of the base time period stands as the standard point of comparison, whilst the values at the other time periods are used to show the percentage in value from the standard value of the base period. So take note of that. Now look at this example. Suppose we wish to compare the average monthly salaries of workers in a given company for 1985, 1990, 1995, 2000, 2005, and 2010, using the 1985 as the base year. So all calculations will be in reference to the base year. So we will be dividing by the base year results. Now, the salary index for each of the 6 years can be calculated using the following relationship. So this is the formula you use. IK is equal to what? The average monthly salary in year K divided by the average monthly salary in 1985. That's the base year. Then you multiply by 100 or 100%. So the average monthly salaries and their computed index number for each of the 6 years are presented in the next slide. And this is referred to as index time series. So that is what you see here. Good. That is what you see. So you have the index time series of monthly salaries. So for 1985 to 2010, these are the average salaries. Now, what are you going to do? The index, you calculate it based on the 1985 salary using the formula here. Okay, so if you go to 1990, you take the salary for 1990, divide it by the salary for 1985 and multiply by 100. That is how you get these percentages. So the first year, that one is the original they pay. So that is already 100%. You keep it there. And you come here, 1990, based on the formula, you divide the salary for 1990 by the salary for 1985 and multiply by 100. And that will give you this result, as you can see here. I didn't show the calculation, so that's what I'm explaining. You can write it anyway where you are recording, so you can play the audio and then we will all be fine. So that is what happens. Per the formula we are working, all those results are were obtained based on this formula you see here. So if you take any particular year, that is year K, so any of the years, all the years, you divide by the salary for 1985 and multiply the result by 100. That is what is giving you those percentages, these indices here. Okay, so this is what is giving you this salary indices here. So for 1990, the salary is 2,000, divided by the salary for 1985 and multiply by 100. Then you get this. Now you go to 1995, you divide the salary for 1995 by the base salary, the base year, 1985 salary, and multiply by 100. That gives you this. You do the same for 2,000. Divide 3,600 by 1,200, multiply by 100. That gives you this, 300%. Then 2005, same, 5,000 divided by 1,200 times 100% will give you this. And then 6,500 divided by 1,200 times 100%, that gives you this. So this is how these indices were found. So one day, if you are given a table like this, so it means I will give you the first two, and then you copy and complete it. So take note. Any question on that so far? Any question? Are we okay with this? All right. Silence means consent.
Sir, please rewind.
I should rewind, but if I did not ask this, you will not tell me to rewind. Why do you wait for me to ask you before you ask me to rewind? Minus 180. Okay. So this is the question. Suppose we wish to compare the average monthly salaries of workers in a given company for 1985 all the way to 2010, using the 1985 as the base year. You have to calculate the salary index for each of the 6 years using this formula. Okay, so if you have to use this formula, it means that the index, the salary index for each year will be the particular year, the salary for the particular year divided by the salary for the base year. And the question has stated the base year to be 1985. So all the 6 salaries, you are going to divide by the salary for 1985, and then you multiply the result by 100. That's how you get the salary indices. So this is the formula. So if you go to the table, that is what is happening. So half for the base year, that's already 100%. So if you like, you can still do it. So if you're in the base year, that will be 1,200 divided by itself, because you take each one and divide by the salary for 1985. So if you divide 1,200 by itself, you still get 1. That 1 times 100, that gives you 100%. So that's how you get this. Then the rest will all be divided by 1,200. Then you multiply the result by 100. So this is 2,000 divided by 1,200 times 100. That gives you this. The next one, 2,800 divided by 1,200 times 100%. That gives you this. The next one, 3,600 divided by 1,200 times 100% gives you that. Then 5,000 divided by 1,200 times 100% gives you this. Then 6,500 divided by 1,200, which is the base year, times 100%. That gives you this. So that is how we got them. Are you okay now?
Yes, please. Thank you.
Thank God it's Saturday morning. So we continue. Now, as you can observe from the above table, you will see that each wage index is a percentage of the what? It's a percentage of that oh, sorry, what am I saying? As you can observe from the above table, you can see that each wage index is a percentage that indicates the percentage of the 1985 salary that were earned in the given year. Okay, so if you take the 1990, it means that the person salary for 1990 is 166.7% of the 1985 salary. If you want to see the difference, that means the increment is what? 66.7%. If you take the 1995 salary compared to the 1985 salary, you see that the result is telling you that the person is taking a salary of, in terms of percentage, 233.33% of the 1985 salary. Then take the 2000 salary, the same thing is happening. 300% of the 1985 salary, and the difference is a bit large. So that is what you see. So for example, as I've already explained there, the salary index in 1995 indicates that the monthly salary in 1995 was 233.3% of the 1985 monthly salary. So that is what you are talking about. So that is what I have explained. Right? We take the 1990 salary, the person is taking what? 66.7% of the 1985 salary. So I can easily give you this table to even interpret it. The interpretation is also key. If I give you this table and ask you to interpret it, you should be able to interpret based on these results here. Are we okay with that? All right. Then let's look at another one. Suppose the unit price of a standard exercise book was 80 cedis, okay, in January, and this 80 cedis rose to 100 cedis in September. The percentage change in the price of exercise books can be calculated as what? The new price minus the old price divided by what? The old price times 100%. Okay. So that is what you see here. I didn't bring the 100%, but that is what it was. I finished solving before I multiplied by 100, then I got it. But that is what you should do. So 100 minus 80, that's the new price, minus the old price, divided by the old price times 100. That will give you 25%. Do you understand that?
Yes, sir.
All right.
Yes.
So that is the percentage change. So you should be able to calculate that. Thank God. Is what? Bismarck, your video is on. So be careful. All right. Let's continue. Now, this follows that the price of standard exercise books rose by 25% between January and September. So that is the interpretation. So as you read, take and pay attention to the interpretation. Whatever you calculate, I can ask you to give me the interpretation. And mostly we award high marks to the interpretation because that is the key thing. It's not about the calculation. So using index number terminology, the 25% increase is added to the base price of 100% to get 125%. That the price index of standard exercise book in September was 125% of the January one. So If you are just talking about the percentage change or the percentage change in price, then you say 25%. But if you want to talk in terms of index or indices, then you rather add the 25% to the base percentage, which is 100. So you, instead of saying there is a change of 25%, you rather say the new price is what? 125%. What do? You add the 25% to the base percentage, which is 100%. So 100% plus 25% will give you 125%. So that is what we mean by that. Note also that any increase or decrease must be related to time period, or else it will be meaningless. Index numbers are no exception. Hence, the January, which is 100% as stated above. This gives the starting point, okay? The January, the base point, gives you the starting point over which the increase in price is being measured. It also emphasizes the base value of the index number. So take note of that as well. 3, if the productivity of a firm measured in terms of labor productivity per day decreased by 10% over the period 2000 to 2006, this 10% will be subtracted from 100, that's the base. So where there is, the base is always 100. Where there is increment, you add it to 100. Where there is decrease, you subtract it from 100 to give an index number of what? 90. So that is what we are talking about here. So if you calculate and there is a decrease, you subtract it from the base percentage, which is 100. If there is an increase, you add it to the base percentage. That is all. This will imply that the productivity index for the company concerned was 90 in the year 2006 as compared to the year 2000, which was 100%. So it has reduced from 100% to what? 90%, which is bad for the company. So take note of that. At this point, let us look at some index number notations. And these notations are useful in the application of the relevant formulas. So you are supposed to take note of these notations, know what they stand for. Okay, if you see P naught in any formula, you should know that it represents what? Price at base time point. It represents price at base time point. Pn represents what? Price at some other time point. Price at some other time points. I'll be giving you the formulas, but if you don't know what the parameters stand for, you can use it. So take note. So P naught is the price at the base time point. Pn is the price at some other time point. Q naught is the quantity at base time point, and Qn is the quantity at some other time point. So take note. You'll be seeing this in the formulas. So at the end of this unit, you should be able to describe the term indices and be able to apply them in investment decisions. You are also supposed to state the different classification of index numbers. So by the time you finish this, what we must do. So now let's start with index relative. Index relatives. An index relative measures the change in a single distinct commodity. A price relative was illustrated in the previous example above, and the productivity relative was computed in as well in the previous example above. Note that there exist, however, more direct ways of calculating index relatives than those demonstrated in the above examples. In the following formulas, we show the method of calculating price and quantity relatives. So this is the formula for calculating price relative. IP. So where you see IP, that is price relative. And this is the formula. It is what? But now you should remember what PN and PO stand for. Okay. This P naught is what? The price at base time period or base time point. And PN is the price at some other time point. So when you see them, you should remember. So index relative is equal to what? The price at some other time point divided by the price at base time point times 100. Quantity relative IQ is also given by what? The quantity at some other time point divided by the quantity at the base time point. That's 100%. So if you see all these things, you should know how to. So if a question is given, you should get all these values, and then you just come and substitute into the formulas. It's just a formula work. And the formula I'll give to you, your duty is to know what each parameter stands for, and then you should be able to implement it. Any questions so far? No question. Thank God it's Saturday morning. Let's continue. So let's look at this example and apply the formulas there. Table 12.2, as you can see below, gives details of price and quantities sold of two items, a video and television, in a particular cash and carry merchandise store over 2 years, 2007 and 2008. So the table shows the quantity relatives for 2008. So it's showing you the price and quantity relatives for 2008. So if you look at this, the table is in two parts. You have the year 2007, that's the base year, and then you have the year 2008. So for both years, you have price and quantity like that. Okay. Now, and these price and quantities are for what? Video recorder and the television. So take notice of them and see how you apply them. You are required to calculate the price and quantity relatives for both items for the year. Oh, who is this writing on my screen like that? Right? I tell Maxwell. In fact, how? Yo. So you are required to calculate the price and quantity relatives for both items for the year 2008 based on the base year 2007, which is always 100%. So you must always remember that the base year is always 100%. So this is how you calculate it. For each of the items, video and television, you must calculate for the relative price and the quantity relative, or price relative and quantity relative. For each of them, you are calculating both. So based on the formula, you know that price relative is given by what? The price at some other time point divided by the price at the base time point times 100%. So go to the table and pick these values. Okay. So price at the base time point, and then price at what? At some other time point. So P naught, Pn divided by P naught. So if you are looking for price, you choose price. If you are looking for quantity, choose quantity. So be careful, you don't just pick anything. So the first one will be what? Pn divided by P naught. So that's where you are having 12,700. I don't know why this zero has shifted this way. So it's 12,700 divided by 12,500. That's for video. The same goes for what? Television. That would be 32,000 divided by what? 30,000 times 100%. Don't forget to multiply by 100%, both of them. So that's what you are seeing here. Okay. So it's as simple as that. If you know how to apply the formula and you understand the parameters involved in the formula, you should be able to solve these things easily. So that's what you see here for the first one. Then the quantity will also be what? Go to the table again. So quantity, so you use the quantity value. So that will also be Qn divided by what? Q naught times 100. So that will be 25 over 40 times 100. So that's what you are seeing here. Okay. So that's how we are seeing it. Then you go and do the same thing for the television. You look for the price relative and the quantity relative. So if you are looking for price relative, go there. For under television, price is relative is what? The Pn divided by P naught times 100. So your Pn, you should know where it is. 32,000 divided by P naught, 30,000 times 100. If you need the quantity relative, that will be what? Qn divided by what? Q naught times 100. So that is all that you see there. Very simple if you follow and understand the procedure. Any questions, ladies and gentlemen? Ladies and gentlemen, yes. So it means everybody is understanding very well. Then I must be a very good teacher. All right. So let me clap for myself. Pa, 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 for me.
So, Doc.
Okay. Yes, sir.
Yeah, so do you need to make an analysis of this?
Oh yeah, you can analyze it.
Can you briefly
explain just as we did in the previous examples. We should be able to interpret, give interpretations to them. So that is that. So if there is no question, we are moving on. The one who wrote on my screen, do that long line on my screen. Will you clean it before I did that? 120 from your marks. In Pesau. Yo. So let's move. So we have moved away from the price relative. Let's look at simple aggregate price index. Simple aggregate price index. Now, the simple price index can be defined as the ratio of the sum of commodity prices in a given current period to the sum of same commodity prices in the selected base year or period. Okay. And mathematically, this is the formula. Simple aggregate price index is given by what? Pn over P naught times 100. So it's the sum. This one is the sum of Bn. That is the sum of prices at some other time point divided by the sum of the prices at the base time point times 100%. I've told you by now you should know what Pn and P naught stand for, what Qn and Qn and Q naught stand for, you should know. So current year's prices and then base year's prices, which is the same as the other explanations that we gave to the notations before. Okay, so that is that. Then note that given the quantity index defined by Qi equals what? The sum of Qn divided by the sum of Q naught times 100%. And the corresponding value index, Vi, is computed by this formula. So that one is a product of the sum of Pn and the sum of Qn divided by the product of the sum of P naught and sum of Q naught times 100. So like I said, I'll provide all these formulas for you so that if there is any question you need the formula, you come and pick and work with. So the only thing you need to do is to understand how to apply the formulas and know how to identify the parameters. That is all. The simple aggregate price index is commonly used in comparing two sets of prices from a wide variety of items. So this is where it is used. You use it in comparing two sets of prices from a wide variety of items. That's where you apply a simple aggregate price index. So take note. Now look at this example. When it is time for your break, you draw my attention so that you go and come. The average consumer prices in cedis per kilogram for some staple food items in 2000 and 2006 are given in the following table. 12.3. They are given in the following table, 12.3. We are required to find the aggregate price index for 2006 using the 2000 as the base year. Okay, for 2006 using what? 2000 as the base year. So the year 2000 is the base year. So you do this and divide it by this, because you always divide by the base year. So that's what you do. So let's see. So it's the sum. What is the formula? Remember the formula. Let me take you back if you have forgotten. This is the formula. So you sum the n and divide by the sum of the naught. So that is what we are applying here. So this plus this plus this plus this plus this divided by this plus this plus this plus this. That's all. So that's what you see there. Are we seeing that?
Yes.
Yes. Yes.
Is there any question on that? So you see the interpretation. Hey, Auntie Gloria, stop writing on my screen. Oh, Tom. Oh, set the screen. I'm about Auntie Gloria. So this implies that, so you see the interpretation to it. This implies that the prices of the 5 items are higher by 95.06% in 2006 than in 2000. You know, 2000 it was 100% because that's the base. We said the base is always 100%. So if you calculate start of 2006 and you get this, now what is the difference? So this start of 2006 is higher by 95%.
I think there is an error there, Doc.
Pardon me?
The interpretation, I think there is an error. Is it 195.6 or 95.06?
Anyway, if have you divided and multiplied? What did you get?
Yes, I think the 195 is correct.
Exactly 195. Is that what you got?
Yes, I got 195.
Divide it again and let's see.
No, it's correct. What the 195 is correct. But in the interpretation here, you put 95.06.
So you divided 433 by 222 times 100%, and you got exactly 195. Exactly.
Calculation. Sir, he's not
Yes.
referring to the calculation. The
What is
interpretation.
The interpretation I mean.
He's not getting it. So, Ture, what said it was that he subtract, you see, it's 100%. And so this one is more by 95. So you subtract the 100 from the 195 to get the 95. So it is more by 95.
That's the percentage change.
Yeah, yes. Yeah, the percentage wise.
Oh, all right. Thank you.
The original one, the base one is 100. So if you get more than that, you subtract 100 from it. And that is what you use to know the change.
Yes.
Whether it is an increment or decrement. So it's an increment. So you subtract 100 from it. What is left is the increment. If it were to be less, that one too, is a decrease. Okay. Zetuli, are you okay?
Yes, I'm okay though. Thank you.
All right. Thank you. So that is that. Then we come to the next one, which is the weighted aggregate price index. The weighted aggregate price index. The other one we just left is what? The simple aggregate price index. And we are looking at the weighted aggregate price index. And the weighted aggregate price index is the ratio of an aggregate of weighted commodity prices for a given year, say K, to an aggregate of the weighted price of the same commodities in some base year expressed as a percentage. Mathematically, this is the formula. Okay. PKI times QKI times 100 divided by what? P naught I times Q naught I. So the K we have said is what? For weighted commodity price for a given year, say K. So you take that and divide it by the base weighted commodity price. Okay, so that is what we do. So it's PKI times QKI times 100 divided by, so PKI times QKI over P naught I times Q naught I times 100. So that's the formula. You can write it out nicely. So let's see what is happening here. We want to apply that formula. And look at the example here. An investor's holding in the shares of 4 companies in 2004 and 2006 is shown in the table below. So this is the table. You have companies A, B, C, and D. And the number of shares for both 2004 and 2006. Then you have the price per share for both 2004 and 2006. You are to use the 2004 as the base year to calculate, 1, a simple aggregate price index, and 2, the weighted aggregate price index for the investor's holding of shares. So for the simple, that's the previous example we did. The previous. Yes, madam.
Please, will the question always tell you which year to use as the base year?
Yes, for sure. Because you need the base. So if I don't give you, if the question doesn't give you the base here, you can solve. So the question will always give you the base. Okay. So everything you do will be based on the base. It will depend on the base. So that is very, very important. You will be given. Okay. And anywhere you see weighted means you have to multiply something by something and find a sum. For simple, you just go straight forward like that. So that is what you see. So you see the simple one. We are not multiplying anything. We are just adding. Then the weighted, you see something times something, something times something plus something, something like that. That is what. So anytime you hear weighted, it means you are going to multiply something by something and sum it. So that is what you see. So we are looking at what? The weighted, the simple aggregate index is what? The sum of the prices in 2006 divided by that of 2004. Okay, so you go to the prices table. You see the prices table, price per what? Yeah. And then the shares. So you just add this. Okay, divided by this. So the sum of this divided by the sum of this. That is what you see there. That is the simple. Okay. Now when you come to the weighted, you have to multiply the shares by the price for both of them. Okay. Oh, sorry. The number for the, yes, for both of them, you multiply the shares by the price. So for 2006 and the 2004. So this is what you see there. You see, for 2006, which is the numerator, you take 400, the shares, and multiply by what? Its corresponding price in share, price per share, plus 180 times its corresponding price in per share, plus 200 times its corresponding price per share, plus 150 times its corresponding 118.75 price per share. Then when you finish with that, you divide all by, you now go to 2004. So you take 350 times its corresponding price per share, plus 200 times its corresponding price per share, plus 140 times its corresponding price per share plus 130 times its corresponding price per share. So you make sure you don't miss the year. The numerator is for 2006. So you take the number of shares times the corresponding price per share. You sum them like that to the end. Then you now divide by the same approach, go to 2004, take the number of shares, multiply by its corresponding price per share for 2004. So that is what you see. Then you finish, you multiply by 100%. So that is what you see has been done here. So they are all just simple formula work. If you understand, as I've explained, you can easily do it, provided you remember and practice what you are doing. So that is how you get it. So if you calculate all this, this is the result you get. Any question for this? Do we understand?
Yes, sir. We
Any
understand.
question? No question? Somebody said something I didn't hear. Okay, I can see something in the chat room. Let me go and read.
There.
Yes, madam.
The question there. Can we go back to the table?
Okay, let me finish reading this message. There's a message from the Auntie Dinah Abaka. Sir, please, what am I? The A. Okay, he says the question A. Isn't it supposed to be the prices to be used instead of the shares? No. It is the prices. It is the shares. Okay. It is the shares. So I think I've answered that. It is the shares. So use the shares. Okay. That's fine. Yes. The second question. Come again, please.
I had the same question, so I think Dinah and I had the same question.
Oh, okay. Thank you. So it is the shares. So that is it. Please, any other thing?
So,
Any other
sir,
Hello,
thing?
sir.
Yes, sir.
Yeah, please, why are you using the shares, not the price?
Let me go back to the formula so that you see it. What the question asks you to do. An investor's holding in the shares of 4 companies in 2004 and 2006 is shown below. Using this as your base, calculate a simple aggregate price index and the weighted aggregate price index for the investors' holdings of shares. So that is why you should use the shares. Okay. Now read this. The weighted aggregate price index is the ratio of the aggregate of the weighted commodity prices for a given share to an aggregate of the weighted price. No, this is that question. One is on the simple. So you go to the simple. Okay. For the simple, you use the shares, not the price. Do you get it? Do you get it?
Very
Okay, so I get it.
So that is not on the weighted. It is the question. He came back to test
Sir,
your knowledge on this. Yes, madam.
sir, please, can you go back to where the formula is again?
Which
Not
one?
this. Not this one. Yes.
Oh, yeah.
Oh, you
Yeah.
said the weighted aggregate price index is the ratio of the aggregate of the weighted commodity prices for a given period. So if we say prices, why are we
And
using?
that is what I'm referring you to that question. The question A is not on the weighted aggregate.
Okay.
So don't confuse yourself with the definition. The question A is on this simple. It's on simple price aggregate. It's on this.
Okay.
So be careful. Don't confuse yourself. So that is the difference. So that is that. Please, any other thing? Okay, then we move on. Then we come to, we are almost done with this slide. Then today we can do more. When we come back from break, we can do more. The break time is supposed to be when 10:30. Was it 10?
10.
Oh, it's another 10. Oh, then it's almost 10. But
Mm.
still, when we come back, we have more time to take another slide. So today we can do more slides. Thank God it's Saturday morning. Now we want to look at the Pashi. No. I knew I've skipped something. I nearly skipped this. We want to look at the last Perez and the Pashi indices.
Sir,
Yes,
the
madam.
question, hello, sir.
Yes, madam.
The question we just solved, there is no
Let's go back there.
interpretation. There is no interpretation anywhere.
Oh, no, whatever it is you have to interpret. That one there, I can ask you to give the interpretation.
Okay.
So that one, by now you are ready to interpret everything. So if I don't mention it, you should prepare yourself for the interpretation. Based on your understanding of interpretations, you should be able to interpret any problem you solve. So that one there, whether I mention it or not, just prepare yourself for that.
Okay, sir. Please, the simple aggregate.
Yeah.
Since we did the calculation on the shares, it means that the interpretation will be on the shares, not the price.
Sure.
All right. Thank you.
Welcome. I like the questions you people are bringing today. They are all nice questions. I like that. So let's move on with the last Perez and the Pashi indices. Mr. Asarif, stop writing on my screen. A last Perez index is a special case of weighted aggregate index. This index uses base time period. It uses base time period weights. It is usually associated with price and quantity indices, where a last Perez price index uses both time period quantities as weights, where a last Perez price index uses both time period quantities as weights. A last Perez quantity index uses base time period price as weight. I don't know if you are getting it. We are saying that it is usually associated with price and quantity indices, where a last Perez price index uses the base time period quantities as its weights, whereas a last Perez quantity, so we are talking about quantity and price. So price uses base time period quantities as weights, whereas quantity uses what? Base time what? Price as weights. So it is period and price. Price index uses what? Period. Whereas that's period quantities. Whereas what? Quantity index uses what? Price or period price. Okay, so it is the other way around. The price index will use the period quantities as weights, whereas the quantity index will also use the period price. So it is the opposite. I don't know if you have gotten the difference there. We have price index and quantity index. Price index will use period quantities as weights, whereas the quantity index will also use the other way, the period prices as weights. So that is what is happening here. Now, the formula for calculating a last Perez index is derived from the general formula for weighted aggregate index. The commonly used formulas are as follows. So for both price index and quantity index, if you want the last Perez price index, is given by what? L last Perez is equal to what? The sum of the product of the price index times the quantity. The price, you see, look at this here. Be careful. This is the price at some time, at some base time point, Pn, times the quantity at the base time period, Q naught. So be careful here. The numerator is a product of Pn and Q naught, whereas the denominator is a product of both the bases for price and quantity, P naught and Q naught. So that is the last Perez price index formula. And the last Perez quantity index formula is based on both the knots, both the bases. That is what it depends on. So the quantity is based on both the bases. So take note of that. Okay. So that is the formula. So you must know the distinction between the two formulas. The price index is Pn times Q naught divided by what? P naught Q naught times 100. The quantity index is what? P naught Q naught over P naught Q naught times 100. So same. So that is that. Now let's take them one by one. Okay, sorry. Now we are looking at, so we are finished with the last Perez. We'll come and solve examples on both of them and then we'll see. Now let's look at the partial indices. Now the partial indices index is another special case of weighted aggregate indices. It uses current time period weights and it's most commonly associated with price and quantity indices, where a partial price index uses current time period quantities as weights. A partial quantity index uses current time period price as weight. So this is also going like the other one. Okay. Price index uses period quantities. Quantity index uses period prices as weights. Now, as with the last price index, the formula most commonly used for calculating a partial index is given below. So this is the formula for the partial price indices. So that one, the first one for price index is both the numerators are what? Both the n's, Pn and Qn, and the denominator. So you see that it is the reverse. Now here, the denominator is what? The base and the new, P naught, Q naught. So you should know this distinction. If not, you will be in trouble. Then the quantity is what? The numerator still both the n's divided by the denominator. Now, when you come here, the n has shifted to what? The price, and the naught goes to the quantity. Whereas the other one, the price was rather the naught and the quantity is the n. So take note of these differences. For me, I'll give you all the formulas. I'll put them there, but you should be able to select the right one to use to solve your problem. So take note. Let's look at example on this. The data. Hey, if your time is up, let me know. Let me see. Oh, it's past time.
Yeah,
And you know, alert me.
it's fine.
Okay, so you go and come and then we solve. Then I think we'll use the first 5 or 10 minutes to solve this. Finish this slide and then we'll go for another slide. So go and come. Let me see when you are coming back. Let's say by 10:35, you should be back. Crane. Break, please. Go and come. I'm also here.
Yes, go.
Okay. I could see that some people are still not back. About some few people, they are not joining. One has just joined. They want to be late comers. Who did that some marks from their marks. So that it will be nice. Okay.
Yeah, they deck.
You be there, be begging for them. So we were on this example. The data that follow is comparison. That is the first one. Then, whereas that Perez index tends to overestimate price increases, and the Pashi index, right? The Pashi, as well, whereas that Perez index tends to overestimate price indices, the Pashi index tends to underestimate price increases. So, what was I reading at the top there? It's increases. So, I said, whereas last Perez
Are these
index,
Latin words or French words?
they are French words. Last Perez and Pashi are French words. So whereas last Perez index tends to overestimate price increases, the Pashi index tends to underestimate price increases. These are often looked at as disadvantages for these indices. Now, the nature of the indices. The last Perez index is thought of as a pure price index as it compares like with like from period to period. The Pashi index is not considered as pure price index since the weights change from period to period, and like is not compared with like. Okay, so when it comes to comparison in terms, so we have compared in terms of calculations, what they calculate, and then we are comparing in terms of their nature, the nature of their indices. So in terms of the nature of the indices, whereas the last Perez index is thought of as a pure price index as it compares like with like from period to period, the Pashi index is not considered as pure price index since the weights change from period to period, and like is not compared with like. And this is the major disadvantage of the Pashi index. So you take note about that. Now, weights used in calculations. Since the last Perez index uses base period quantities as weights, the index can be outdated, whereas Pashi index uses current quantities as weights, and hence it is always up to date. Now, the ease of calculation, simple way of calculating the index. The last Perez index needs only the base period quantities, no matter the number of what? Periods. The Pashi index needs new quantities for each time period. So for ease of calculations, whereas the last Perez index needs only the base period quantities, no matter the number of periods, the Pashi index needs new quantities for each time period. Now, these are the uses and limitations of the index numbers. We look at the uses of index numbers. Index numbers are mostly used to reflect changes in general economic conditions over identified period of time. For instance, the retail price index, RTI, measures changes in the cost of living. The index of industrial production reflects changes in industrial output. And the ordinary share index reflects the general state of the stock market. Index numbers are used by policymakers to decide on tax changes, subsidies to parastatals, industries, and so on. Trade unions use national cost of living and production indices in negotiating for wages or in comparing the cost of living across national boundaries, states, or professions. Insurance companies use various cost indices to index link house policies. Other uses of index numbers include: 1, determination of real economic values. So in periods of inflation, the actual value of a commodity does not serve as the best guide of its real value or worth. The worth of any commodity can only be measured relative to the value of associated commodities. Some relevant indicator, such as index number, against which to judge value is necessary. So, for example, suppose the annual rent of some business shops last year was 250,000, and this year it has been increased by 10% to 275,000. You can observe that the actual cost is higher. If we obtain some information that the cost of business shops in the state as a whole has risen by 15% over the past year, you can rightly argue that the real cost of the given shops has decreased. But if business turnover for the shops as an alternate indicator has only increased by 5%, you may argue that the real cost of the shops has increased. It follows that, depending on the particular indicator chosen, the real value of a commodity can change. So that is clear. There are two major types of standard national indicators. These include rate of inflation, which is often represented by the retail price index, and then the index of output of the production industry. So take note of that. Then we also have another use of these index numbers. It is also used in time series deflation. And what is that? Time series deflation is used to obtain a set of index relatives that measure changes in the real value of some commodities with respect to some given indicators. In general, given a time series with X values and some indicator index series with I values for comparison, the real value index, RVI, for period N is determined by the formula as you can see. So the real value index will be equal to the current value denoted by Xn divided by the base value denoted by X0 times the base indicator I0 divided by the current indicator In, all multiplied by 100%. So in short, if we take the symbols, we say Xn divided by X0 times I0 divided by In times 100 gives you the real value index. Let's do an example on that. The following table presents the values of the average daily wage, N, and relative price index for 8 months. You are required to compute the monthly real wage indices. Monthly real wage indices. So this is the table for the 8 months, month 1, the first month to the 8th month. Daily wage has been quoted here for the various months, and the retail price index has also been quoted. Okay, so you are to compute the monthly real wage indices. Monthly real wage indices. So it is the formula you have to use. It is the formula you have to use. So the current value divided by the base value times the base indicator divided by the current indicator, all times 100. So for the starting point, the first month, like we did in the previous example, the first years are 100%. So whatever you calculate, you should get 100. So if you like, you just write straight that is 100%. So month 1, we take x over x. It is the same thing. The new and the old are the same. That's why you see the first month, 17.60 over 17.60. Then the x base and the x new are also the same. So 106.1 over 106.1 times 100. That's why I said the first one, if you like, you just write your 100% because it will not change anything. So that is the first one. Then you go to month 2. When you go to month 2, the month 1 becomes the base. Okay? And then the same. So everything in month 1 will be the base when you are in month 2. So month 2 figures will be the new. I hope you are following that. So that is what you have to see. So you see month 2. So the month 2 figure is the new, and then the base. Okay. And then, so when you go this one, you remember for the beginning, xn, so the new, divided by x naught, the old. So that is month 1. So month 2 over month 1 times the I, you begin with what? The old, that's the naught, divided by the new. So that is how it goes, times this. Okay, so that is what it happens. If you go to the next third month, that of month 2 becomes the base. So that's why you see in the third month, month 2 is the base. But why am I having this 90? Let's see. Yeah. You go to the third month, okay? So from the beginning, the first month is now always the base for you for judgment. So everything will be divided by the first month. So based on the formula, go to month 3. The month 3 value is the new divided by the base, which is the first month. And you go to this one too, the base will always be the first month. That's the indicator, I. So you can look at the table. So these are always going to be the base. This is the base for what? X. And this is the base for I. So they will always, wherever you need a base for I and X, you come for them. It is the news that will be changing according to the months as you move along. So that is what you see. So that is what you keep doing for all of them. So this is month 3. You go for the month 3 value, that is the new. Divide it by what? Month 1 value. You come to the I, the old divided by what? The month 3 value, the new. So that is what you see there. So that's what you see. Multiply the result by 100, you get your result. You go to month 4. So you do it for all the months. So if you go to month 4, you pick the month 4 value, that is the new. So that's what you see. The month 4 value is the new divided by the base. Then the base for I divided by the month 4 value as the new. Then you multiply by 100. You go to month 5. The month 5 value will be the new divided by the base times the base for I divided by the month 5 value. You multiply the result by 100. You go to month 6. Month 6 value becomes the new divided by the base times the base for I divided by the month 6 value as the new. Then you multiply the result by 100. You go to month 7. It is month 7 value, which is the new divided by the base times the base for I divided by the month 7 value. You multiply the result by 100. And the last one, the month 8 value is the new divided by the base, multiplied by the base of I divided by the month 8 value multiply the result by 100. So that is what you see has been done for all of this up to the end. So this is what that means. And when you finish, you must give your interpretation. So you see that the last real wage index indicates that the average daily wage had increased by what? 8.2% over the 8 months period. In real terms, wages increased steadily, except for month 6 and 7. So if you compare, let's see month 6 and 7. Month 6, month 7. Month 6, the increase was what? That's 4.02. And month 7 to 4.2. So it's just similar. But the rest, you saw great increases. Let's see the others. You see, so it was increasing steadily. From month 100%, month 2, it went to 100.94. Month 3, it went to 102.03. Month 4, it went to 106.6. Month 5, it came down to 105.2 at a point. So you can follow this and give the interpretations as to where it is increasing steadily, where it is coming down, where it is stable. You should be able to look at the figures and then interpret. So that is what it takes. Any question on that problem? Do you all understand how this has been solved month by month based on the formula? Is there any question on that? The Nepal, no question, eh? Thank God it's Saturday morning. Okay, so that is that. Let's move on. Want to look at the limitations of index numbers, the disadvantages, the weaknesses of index numbers. And the limitations include, among others, 1, indices give only general view about economic changes over wide geographical areas. It follows that they will not generally cater for minority groups or professions or major regional variations. For instance, an individual's food bill for a particular month may have increased significantly enough, though the food index or retail price index for that month may have shown a decrease. So we are saying that these index numbers give a general view. So maybe the majority carries the day. So if they conduct the survey and the majority think that their economic price or maybe their food prices have reduced significantly for them, then maybe you are in the minority, you alone in your house, it's rather increased. When they are presenting this to the general public, they will present the majority view, not the minority view. So that is a major weakness on this. 2, weighting factors can become outdated, that the index may fail to compare like with like. So that's another point. It may fail. There can be an error somewhere. In everything we do, there are errors. 3, if samples were used to obtain data for either values or weights, the information obtained might be biased, incomplete, or false. So if you go in to conduct a survey and maybe you, the one conducting the survey, you have a special interest somewhere that the politicians have been doing, they will just go and conduct their own survey and come and say, yes, they are winning. But their survey, they are winning. So they will go and ask their own party members, will you vote for party A or party B? Then they know definitely the answer. The person they are asking the question will say they will vote for them. So they will just go and pick such people and come and put in the public domain that their survey, the research they have conducted, they are winning, they will win. So during elections, you see both parties, NDC and MPP, coming up with surveys that indicate that they will win. But in the end, only one of them wins. I don't know when the two of them will win together. Maybe next election, or I don't know. We keep waiting. So that is that. Now, so that is that about what biasness. So if you, the researcher, you are already biased, you know what you want. So you tilt the survey in that direction, you will be biased. 4, index numbers can be misinterpreted by uninformed lay persons. Good. So if you go and you conduct this survey, maybe you are conducting a survey on what? Academics. And you go and ask market women. You go and survey, do your sampling from market women. What do you expect? What result do you expect to get? So the people you are interviewing have no idea. They are lay persons. They have no idea about what you are talking about. So all the information you get from them are uninformed information. So you can't use this for any proper thing. It is wrong. So the index numbers can be misinterpreted, but by uninformed lay persons. So take note, these are all limitations. So that is how we end index numbers and their limitations. If there's any question, let's ask. If not, we see what to do next. I wanted to take another slide, but I think I don't need to pile up too much on you. So if there's no question on this and we are okay with this, like somebody raised the issue about the last example we did last week, then I'll go for that example and then we'll see what is good about it, and if there's something to correct, we correct it. Any question? In Nepal, no question, eh? Maybe today we'll close very early and have some peace. If there's no question, I'm bringing this slide down so that I go for that last example and bring it, then we discuss it and clear all possible doubts. Thank God it's Saturday morning. So let me bring that one. Where will I see it? Jack, where are you? Jack, where are you? Jack, where are you? Jack, where are you? Let me see if it is this one. Yes, I think it is. Can you see the screen? Hello?
Yes, sir, we can see the screen,
Yes,
sir.
yes, we can see.
Okay. So this was the example, the last example.
The other example too, the first example that we solved under the maxima and the minima.
Yeah, that's it. That's what I
No,
mean.
this is the
Is that
second
not?
example. I mean, there's a first example too.
You mean the first one?
Yes, the first and the second, both.
But the first one, did you have any issue with that one too?
No, I'm saying that the both solutions that you wrote, they were correct, right?
Okay.
You told us to change them, so I'm saying that they were correct. The solutions that you provided were correct.
Okay, let's go through this one and see. Let's go through. All right. It says the demand equation for a manufacturer's product is given by P is equal to 80 minus X divided by 4, which is the same as 20 minus 1 over 4X, which is the same as 20 minus 0.25X. Now the question is, at what value of X will there be a maximum revenue? And the second question is, what is the maximum revenue? So if you are able to determine the value of X at which there will be a maximum revenue, then you should be able to use that value to find the actual value for the maximum revenue. So this is the question. And we said, by definition, revenue is equal to the price times the quantity. So the quantity is the X. So if we have a revenue function to be 20 minus 0.25x, then we multiply that by x, and that will give us 20x minus 0.25x squared, as you can see here. So this one has no problem. However, the question we want to answer is, at what value of x would there be a maximum revenue? And we know from our definition that at the maximum or minimum point, the first derivative or the first differentiation, the first differential of the given function must be equal to 0. Okay, so you differentiate the function and equate it to 0 and solve for the value of x. So that is what we do. So now that we have this function, 20 r is equal to 20x minus 0.25x squared, what do? We have to differentiate it. That's what we call the first differential condition. So we'll differentiate it. We take the first derivative. So if you differentiate, so that's what we call the r dx. Now, if you differentiate r with respect to x, this function, if you differentiate this with respect to x, that becomes 20. If you differentiate 20x, you get 20. If you differentiate 0.25x squared, the two will come and multiply the negative 0.25. That gives you 0.5 negative. Then you subtract 1 from x, you are left with 1. So it becomes 0.5x. So this is the first derivative. It is this first derivative per the what? First differential condition or first order condition. You would then, after you have differentiated this, you equate it to 0 to determine the maximum or minimum value. So you set this result to 0. So this 20 minus 0.5x will be equated to 0. So if you equate it to 0, then you solve for x and make x the subject. So we said 20 minus 0.5x is equal to 0. Then from this, we made x the subject. Okay. Good. So we said 0.5x is equal to 20. Then we divide 2 by what? 0.5, and we had 40. Okay. So when we had 40, we said that, what does that 40 mean? The question said we should find what? The value of x at which the revenue is at maximum. So the value of x is what we have found now to be 40. So that's the value of x at which the value or the revenue will be maximized is 40 units. It is where the solution ended. So the solution is not complete. We didn't solve the B part. Have you seen it?
Yes.
Are you there?
Yes, I'm there.
Yes, sir.
So the solution is not complete. We only solve this. What is on this slide is only for the A part. We didn't solve the B part. So let's continue. But I don't have it on the slide. So unless I say it, then you write. So let me say it, then you write. So this is the A part. That is correct. As you said, there's no problem with the A part. It is correct. Then let's go to the B part. So let's answer the B part. Are you ready? So write it. I don't have it. I didn't type it anywhere. But I have just realized that we didn't solve the B part. So let's solve it. So if you are ready, let me know so that I say it, then you write.
Sir, we are ready.
Sir, we are ready.
Okay. So the B part, where they say we should find the maximum revenue. So, right. By the second order condition, d raised to the power 2, small d, I mean the way we wrote this one, write the same thing. I believe you can see my cursor.
Yeah.
D, but the D here, raise it to the power 2. That is an indication that you are taking the second derivative. So the D raised to the power 2 before the R comes. Divided by dx. Now here, you raise the x to the power 2. Have you done that?
Yes, sir.
Yes,
So
sir.
that should be equal to, if you differentiate this. So you are now going to differentiate this again. So if you differentiate this again, you only get negative 0.5 as your answer. So d squared r over the x squared should be equal to negative 0.5. Are you there?
Yes.
And that should be less than, is it less or greater? If you have negative 0.5, is it less or greater than 0?
It's less than
It's
0.
less than 0.
Is less than 0. So if it is less than, if you take the definition of maximum or minimum point, if you take the second derivative and the answer is less than 0, is it a maximum? Is it an indication of a maximum point or a minimum point?
Maximum.
So it's an indication of a maximum point. So when you take the second derivative and the result is less than 0, it is an indication of a maximum point. If it is greater than 0, it is an indication of a minimum point. But in this case, it is less than 0. So you put into bracket maximum point, and you close the bracket. Are we there? Can I continue?
Yes, yes.
Then you continue. Hence, why do we always say hence? Hence. So what about goats and sheep? Don't write hence, write
Therefore.
goats. No. Hence, if you use hence, why don't you use goat or sheep? So use any of them too. Yes, sir. In Ponching, you know, Omububefu said that we are Kokonkwana Moka. And I hence, and then young Koko Baby Namoka.
There be different spelling is different.
You and the materials here, and there you can use anyone. So hence, maximum revenue into bracket capital R is equal to 20. So you know what we are doing now. So now that you have found or proved that there is a maximum point, it's an indication that the 40 that we got as the maximum value of x, you now go back and substitute that value into this function, the beginning, the original function, 20x minus 0.25x squared. You now go and substitute it there. So wherever you see x, you put the value for x there and solve, because that is what is going to give you the maximum revenue, the value for the revenue. So that is what we are going to do now. So we are now going back to the original function, and then we'll substitute the 40 for x, because we are saying x is equal to 40. So wherever you see x, you put 40 there and solve. The value you get is the maximum revenue. Okay, so that's what we are writing. So hence, the maximum revenue R is equal to what? 20 into bracket 40. That is 20 times 40. So you close that bracket, minus 0.25 into bracket 40 squared. You close the bracket. Are we there?
Yes.
To solve it, what is the answer? What is the maximum revenue?
I think 400.
Yeah. Yes. So this is how we should have concluded. So the maximum revenue is 400 cedis. That's all. So we didn't finish. We only solved. What I had on the slide was for only the session. I'm sure that was what was confusing me that day. That because I was looking to get the maximum revenue for the B. and I wasn't seeing it.
Okay.
At times when I'm a bread, I didn't my bill.
So anyway, the other one too, we didn't do this, the B part too, the first example.
No, the other one, did they ask you for that?
Oh, they didn't add.
They didn't ask you
They
for
didn't
that.
ask, yes, they didn't.
They didn't ask, so that is it. All right, so if there's nothing else, ladies and gentlemen, here is where I bring this lecture to a close. Praise the Lord.
Hallelujah.
Thank you, Lord.
Once I've become your pastor, at the end of the church service,
Offering.
to give offering. So chapel stewards, bring the offertory bowl and let's do silver collection. Hallelujah, amen. Hallelujah, amen. So drop your offering. Drop. Bye-bye. See you next
Are we
week.
meeting next week?
Yes, next week is the face-to-face. Is that not it?
Yes.
So we'll meet next week.
Set time.
The time will be, let's do it from 9. Yes,
10.
from 9.
10.
You want it to be 10, eh?
Yes, please. Because of traffic.
All right, I don't have any problem.
Hey, what are you
Okay.
are talking about?
But I
What
think we
about
are
the
having
other
2
lecture?
classes there. Hope the other class
Let-
You forgot
No.
that we have another lecture.
Yes.
Dog, are we going to have a class or is just revision?
We'll have a class before the revision. The revision, no, but you have we have a revision week we will do online.
Yes.
Oh,
Yes, please.
So we'll have a class.
After
and then
his
maybe
class, we will still have another class. So let's look at
So,
it.
so please let's meet at 8.
No, 9 is okay.
So we are having 2 classes.
8 is
So
too
I
early,
think
please.
8 is too early, but we can make it 9.
Sorry, I'm watching. Why? See, I'm watching.
No, 9. No, let's all 9. I think 9 is fair.
Yeah, 9 will be fine.
okay.
8 is
So we'll have what I'll do is that maybe if I'm able to do enough, maybe the online revision we may not do. So what I'll do is that maybe we'll meet, do the teaching, the last things that I have to teach that, and then I'll give you some few tutorials for your revisions, and that may be all.
And okay.
All right.
Thank you. Bye-bye.
Bye-bye.
Now, do we have a lot to cover till you finish?
Oh, not much.
So okay.
At least by now I have finished putting my questions together. So at least I have a fair idea of what tutorials to give. So that's it.
Thank you.
Thank
Welcome.
you.
See you next
Your
week.
classes has been interesting.
Eh,
Very
is
participatory.
it because I have been doing concerts?
No, it's also good. Sometimes
Yes, it's because of the concert.
I think it's also it's part of it. It's
It's not
okay.
straight. At least
We've enjoyed
there's
the
some kind of
class.
Yes, it brings us some. I mean,
release a lot of stress. The calculations are too
We've
much.
enjoyed your class.
That's fine. Thank you. I wish you
At
well.
the end of the day, we will do some offering for you.
Oh no, since I'm a pastor, and the pastors usually they take off a tree and then they tithe.
Yes, sir. I'm the treasurer, so I'll collect it for you.
That's it.
Self-appointed treasurer.
Of course.
All right.
Okay,
Bye-bye.
Nice day. Please. Hello, class.
Yes.
Class.
Papa Sam, are you there? I don't know about others, but with the research, I think we were contemplating if we can get a little bit of extension of the date. It looks like we might not be able to submit tomorrow. I don't know about others, whether others are finished, but with our group, in fact.
It should be done before 12 a.m.
What research are you talking about?
I think you can send that in your research platform.
There's chapter 1 and the chapter 2. We are to submit it.
Chapters 1 to 3, right?
No, 1 to 2, 1 and 2.
Oh, okay.
We are to submit it by I think today, by 12 today, right?
Yeah.
Derek Mate, you are not part.
You are not part of.
We are not part.
Last semester.
Sorry.
Research.
Those of us in the
Oh, okay. So this is the January people.
January cohort.
I'm going to detect. You make the way she make my heart hot.
I rise the temperature. Sorry. So I don't know about others, but our group, see, with the literature reviewer, if you want to do a very good job, you need to read a lot of the other researches you downloaded for you to be able to put together a very good literature review work. And it takes a lot of reading to understand what others have written. So as we speak, honestly, we are not done. And I don't think by midnight today we'll be able to finish. So I don't know about others, but if you ask me, if all of us agree and we tell her that we have not been able to, so at least you should extend the date for us. I'm sure if it's a collective something, she will not deny us that. So I don't know about others, but our group, honestly, we have not been able to finish.
I agree with you.
Awesome.
Please, let's speak up so that if it's a collective thing, so that it doesn't come from just one group.
Not to give it, not to give us some of us blood pressure.
No. Sorry.
Well, you can try.
So members, please, let's speak up so that if we go as a collective, as a team, and request for an extension, I'm sure she would consider and then extend it a little bit for us.
Yes.
Class rep, Papa Sam, are you there?
Papa Sam.
He's not on the platform. I think he didn't make it today.
He left.
No, he was
left. He was online.
When we started, I saw him, but it looks like he left at the moment.
He was not feeling well, so I don't know if he's okay now.
So there, please, other groups, are you done? Are you done with your work?
No.
So down with your work so that we know what we do.
If we all have similar challenge, then let's come together as a group and then request for an extension. That is all that I'm asking for. But it looks like people are not even interested in what I'm saying. If others are finished, right, but some of us have not finished. This Mark, your line is no, your network is not good, so we can't hear what you are saying.
Cover off.
Or we should continue on the research platform.
Let's continue about it. Let's go and continue about it because since most of them have left.
Yes.
Okay. Then we'll call it a day.
Thank you.